There's a few problems on foundational exam number 4 that essentially are asking you what happens when you take the sum or difference of two numbers or variables and raise that to a power of something. So for example, you'll see like p minus 4 all squared. And depending on the problem, you'll have possibly a list of various combinations or variations on this expression asking which are equal and which are not equal. And so this question's been giving people some trouble, so I'm going to kind of walk through the thought process on it. So there's two ways that you could work out what this product here is, so p minus 4 all squared. The kind of long, hard way is to use the distributive rule twice in a row. So something squared is just that same thing times itself. And then from here, you take the first difference, distribute it onto the second difference. So this p is becoming that p, this negative 4 is becoming this negative 4, and then we're splitting this this term here into two places, factoring out. And we factor out a second time, and factoring out just means using the distributive rule backwards. And then we get this long expression. You crunch it all together, and so you get that p minus 4 all squared is equal to p squared minus 8p plus 16. A lot of the homework problems will leave the 16 as 4 squared instead of expanding it out. And then a lot of you have learned like this kind of square method where you take your difference of two numbers here, so in this case p and negative 4, you draw a box with this on the side and on the top, and you multiply in each row and column. So top left, for example, is p times p, so we write p squared. Here we're in the column for negative 4 and the row for p, so we'd get negative 4p. And if you add all four of these things together, sure enough, you get this answer, p squared minus 8p plus 16. Okay, so what's the big deal? There'll be misleading answers. And so one of the ways that you can encounter a misleading answer is it'll hide this negative 8p. And so it's tempting because it's easy to look at this and think, oh, okay, I just move the squared onto the 4 and onto the p. So p minus 4 all squared is p squared, negative 4 squared is plus 4 squared. Another similar error is these problems will switch a sign somewhere, usually this one here. Again, it's easy for your brain to think, oh, okay, well, we have p squared, we get p minus 4 all squared, we get a p squared minus 8p, and then minus a 4 squared. So, oh, but that's not what happens here. You don't get a minus 4 squared, and the reason for that is if you look back through this kind of weird double factoring thing we did, we get a minus 4 times a minus 4, so those minuses still cancel out and we get a plus 16. Same thing with the box method, minus 4, we get a plus 16. And even though there's a minus here, the minus does show up in the answer, but not in front of the 4, it shows up in front of the minus 8. And then similarly in general, if you have higher powers, so cubed to the 4th to the 5th, you're not going to, so say we have p minus 4 all to the 5th, you don't get p to the 5th minus 4 to the 5th. There are some weird like higher algebra like places where this actually does work, but anywhere that you'll be encountering in a basic calculus course, you won't have to deal with this being true. You can always just assume this is false, and there's going to be a lot of extra stuff that shows up in between the p to the 5th and the negative 4 to the 5th. In this case, you do get a negative, and that's because we're multiplying negative 4 times itself 5 times. So the first 4 negatives will cancel out, and the last one will give us a negative sign here.